Okay, so today's learning objective is to apply the properties vertically opposite angles, understand and use alternate and corresponding angles on parallel lines. And so what we'll be doing today is kind of establishing some common facts regarding angles and parallel lines that you use quite a lot, and we'll just be kind of talking through them and using kind of the knowledge we've already established about how angles on a straight line add up to 180 degrees to work through that. So, as I kind of just skip to, if we, okay, that's not what I need. Okay, so if you remember about how I had a circle, and let me make some space. Last video we talked about how we have a circle, and then that's a very badly drawn circle. How we have a circle and how we can figure out that angles on a straight line will be 180 degrees. And if we draw another line through this, for example, we know that if there were this is cut into angles, say x and angle y, we know x plus y would add up to 180 degrees because angles on a straight line add up to 180 degrees. And we kind of figured this out, right, from how from the idea that angles on around a point will be 360 degrees, we can figure out angles on a straight line will be 180. We talked about that last video. And so if we draw, say, two lines, like this, and if we draw another line through it, so this is line 1 that continues on to infinity, and this is line 2 that continues on to infinity. And because of this line, we have they intersect at, let's say, point A. And if you remember last time around, we talked about how A can be a vertex, and if we have, say, point B here and point C here, we make the angle CAB, cap, and then let's call this angle CAB x. Ooh, I went a bit too far. Let's call this angle x. Well, from the fact we've established that angles on a straight line add up to 180 degrees, right? So sorry. So this thing over here must be let's call this y right now. Let's call this y. But we know that x plus y must equal 180 degrees, right? Because angles on a straight line add to 180 degrees. So y is equal to 180 minus x, which is equal to 180 minus x. And then, but we're also given this angle z. So that's another angle. And we also know, z plus y equals 180. So let me actually change the color of z. Let's make that orange, z. We know z plus y is equal to 180. But we know y is 180 minus x, so z plus 180 minus x is equal to 180. If we take away 180 from both sides, we're left with z minus x is equal to 0, which means z is equal to x. So instead of writing z here, we can just write x. And by the same logic, right, so, well, actually, we can see that these are what we call vertically opposite angles. Because we have, they're opposite and they're separated by these two lines, right, so that makes them vertically opposite. And we have the theorem, basically, that vertically opposite angles are equal. If x and x are equal, and we also have, say, by that same logic, y, if this is y, then this is also y, because these are also vertically opposite angles. So that's our first thing, that vertically opposite angles are equal. And then the other fact that we have is something known as corresponding angles. So this time, let's consider two parallel lines. So we have let me get the line tool out here. Okay, so we have this line here, and we have another line, which is parallel. And to indicate parallel lines, what we actually do is, on the line, we'll have a sign like this, like this arrow on it, showing that this line and this line are parallel. And remember what parallel means? It means they're never going to touch. That's one of our ways. And let's think about another line that that goes through that. That's bad. That goes through it like this. And if you go ahead and label a few points, we can label this point A, label this point B, for example, B, and if we have kind of, let's say, let's just go back to black, call this, say, C, call this D, and call this perhaps E here. Well, in fact, instead of labeling these, why don't I just do something, I'll just say this angle here, this is X. Our corresponding angle theorem says that if this angle is X, then the angle up here is also X, i.e. this angle, and this angle are equal. And kind of using that same principle, you'd also have this angle, let me change colors. You'd have, this angle Y is equal to this angle here, Y, and, the same thing on the other side. And the proof of this is in kind of, I've included this in a separate video. You don't need to know the proof. It might help you with a kind of, instead of just me telling you and you accepting it, it might help you to see the proof. But once we kind of have this, we've kind of established that this is kind of one of the big proof, one of the kind of key facts that you need to use, and it's called the corresponding angle theorem, i.e. corresponding angles, which are basically angles kind of, if there's two parallel lines, right, and there's a kind of another line that cuts through both of them, corresponding angles are kind of the one here and the one here, for example, or say the one here and the one here. So that's what corresponding angles look like, and we're told that they're equal. So from this, we can actually establish a few other facts. If we know x and x are equal, right? That's true. Well, we can also think of, say, the angle here, y. And we know that x and y are both in the straight line, and the angles on a straight line sum to 180, right? So x plus y equals 180. So y is equal to 180 minus x. And if we know y is equal to 180 minus x, we can also see that, if we think about, instead of adding that x, let's add this x and this y. So x plus y, well, we already know x plus y here is 180, right? And if we kind of do this, we'll find that out as well. So basically, this is what we call the co-interior angle theorem. That means that angles kind of, when we have two parallel lines like this, so two parallel lines, there's another line kind of going through it, the angles on the inside, like this, will add up to 180. That's co-interior angle theorem. That's the other one. And we also have kind of this interior alternate angle theorem. So if this is y, right? So this is y. And remember from our kind of opposite angle, vertically opposite angles, if this is x, right? This is also x. And this is what we call the interior alternative interior angle theorem. It kind of, when you have these two parallel lines and you create kind of this this Z type looking thing, like this. Ooh. The angle here and the angle here are equal. And also you could create kind of a Z. So if I can get rid of this, you can also create, say, this is kind of a, this isn't a Z, but you can see how this kind of looks like a Z but flipped. You also have, say, this would be Y as well, if kind of by the alternate interior angle theorem as well. So that's kind of with parallel lines, these are the key facts you need to know. And I appreciate I haven't written them down, so I've got this kind of nice looking infographic here, which just summarizes all of these. We've basically, we've used the fact that angles on a straight line add up to 180, this one here, and that kind of the corresponding angle one, which I'll prove in the next video. I'll say next. To prove that kind of co-interior angle add up to 180, we've done that. To prove that alternate angles are equal, and vertically opposite angles we use just from the fact that straight line, and kind of we'll prove this angles in a triangle add up to 180 in another video. So these are the facts that you kind of need to know, and you basically just, you could, I guess, prove them to yourself just if you just remember this one, you could technically just prove the rest to yourself as you go along. But that's a bit kind of harder to do, and a lot of the time questions kind of ask for an explicit statement of saying kind of what's the reasoning behind it, and you have to kind of remember the names for these. So it's really important you kind of just look at this and kind of actually just memorize it. It'd be nice if you do remember the proofs. It will probably help you remember them. But if you can't, just make sure you remember kind of what each of these angles, kind of these reasoning and theorems are, and what the names of them are, and what kind of corresponds to them. You'll see why in a second. So the question types that you get with these is something like this. You're given an unknown and you're given another angle, and you're asked to work out the angle marked x. So ABC, and DEF are parallel lines. And look, we've got the arrow here to prove it. Or kind of not prove it, but the diagram showing it. And BEG is a straight line, another straight line. And the angle GEF is 47. Work out the size of the angle marked x. So the reason they have something like diagram not accurately drawn is so you can't just get your protractor out and measure x, which would kind of be a bit easier than using the theorems we have. So that's why they have this. Don't try getting your protractor out to measure it. So what can we use here? So basically, when I see questions like this, right, where you have to find an unknown angle, I basically just think, from this one angle I have, what facts can I find out? Just try labeling any angle I can find out. So if I know what 47 is, if this is 47, I know what this angle is straight away. Just because, from the vertically opposite angles, I know this is also 47. So that's the first thing I do, kind of look at the angle and think, what else can I label? And I can also label that, since they add on a straight line, angles add up to 180, I know this is 180 minus 47, which is, I'm just going to calculate this, is 133. And now from this, I kind of have more angles, right? And I can perhaps get a bit closer to finding what x is. I could use, for example, knowing that this is 47, right? I could use my co-interior angle theorem, which says that kind of co-interior angles add up to 180 degrees, to say that, then say 47 plus x is equal to 180 degrees, and then find x. So the way you label this is, remember, you see here how it says give reasons for your answer. So you basically need to show step-by-step working. It helps to label the diagram, but you need to say how you figure everything out. So you can say, so this is where it's important to know the notation as well. So you say angle, DEB is equal to 47 degrees. And then the reason you put in brackets, you say vertically opposite angles are equal. Or equal. Okay, we know DEB is 47. And now we can say, x plus 47 is equal to 180 degrees. And then we have the co-interior angles sum to 180 degrees. And this is kind of our reasoning on the right again. And now we have x is equal to 180 minus 47, which is 133 degrees. And there you go, you have x. Work out them, and there we go. That's our kind of answer. So it's really important if the question asks you, and sometimes even if the question doesn't ask you explicitly to give reasons for your answer, if you work through it step by step like this. So again, first thing you do is just look at the diagram. If they haven't given you a diagram, really important to draw one. And then just kind of try labeling the stuff you have, and you can kind of work through to get to the answer, right? You can almost do that in your head. You can say this is 47, so this is 47. Oh, and I know co-interior angle theorem, done. And then once you have the answer from that, you can kind of work through it, writing it here, or if you're not too sure how to get to the answer, just do it step by step. Say this, and then if you can't, you can just write that step down and then see how it goes. Another question as well. So DE is parallel to FG. Yeah, we've got those arrows. Find the size of the angle marked Y. Okay, so how are we going to do something like this? So we have a few angles that we're given, and we can kind of try just labeling them. So, we could say if this is 62, then this is 180 minus 62, because the angle's on a straight line. So 180 minus 62 is 118. Okay, but what do I do with that now? I can find this angle here. That won't be too helpful, right? Because with this angle here, what else can I find that, I can't really see how else I could how that'd be any use. So, with this 118, I can calculate this angle, for example, because they're parallel. So the co-interior, so this is 62, and this is actually just the alternative interior angle theorem as well, right? Like 62. Look at that Z. So that's 62. Okay. Doesn't seem to be helping me too much. So let's try using the 64. Oh, and you might, for example, spot that this is a Z, right? And looking at the z, remember this is the alternative interior angle theorem, so y must equal 64. And there we go. And you can kind of almost guess from the question that, so this is only a 1 mark question, right? So you can kind of tell that it will only be kind of one step of reason, kind of one step, or kind of it will be easy enough to get, because if this is only 1 mark for this, and you can give reason for your answer, there's only 2 marks here, so you can kind of guess it's not going to be too complicated. So you can just say y equals 64 because of alternate interior angles are equal. And there you go. That's all there is to it. So I think that all made sense. I know there was quite a few different things I've talked about in this video, but really important to commit these angle facts to memory, or at least and kind of remember the names that come with them, because they're super important with questions like these. And with questions like these, eventually, if you do enough of these questions, you just spot the answer straight away. You just kind of you can see these z's, really easily, and you just kind of, all your facts, because you've done the questions so many times, you kind of know what facts to use straight away, which kind of saves you from kind of fumbling around as I did in the beginning. If you're very well versed in the question, you can just see kind of the z straight away, and boom, you got the answer. So it's really, really important to practice. I know I say this basically every video, but with these angles in particular, this is one of the places where practice is some of the most important thing, because or else it's hard to see kind of patterns like these, I guess. So hopefully that all made sense, and I'll see you guys in the next video.